Hi students, today we will discuss a problem on trigonometric equations. The question is the solution of mod cos x equal to cos x minus 2 sin x is looking very simple question but a very conceptual question. Just see the explanation for this question. Just listen carefully and watch till the end. You will understood the solution. Now the first question is modulus of cos x equal to cos x minus 2 sin x, and here there will be two cases because of the modulus present here. Now coming to the case 1, in case 1 I can say that modulus of cos x will be positive. For suppose if mod cos x equal to cos x, it is possible only in which quadrants? Either first quadrant or fourth quadrant, right? Either first quadrant or fourth quadrant. So that will be positive here in this region, right? In this region it will be positive. Clear? Then in case of mod cos x is cos x, then from the given equation cos x equal to cos x minus 2 sin x, so that cos x cancel. So we can say that clearly sin x equal to 0, and sin x equal to 0 we can say that x equal to n pi, where n belongs to I. So don't think that it will be the final general solution because of, now let me check x equal to n pi. For suppose if I take n equal to 0, I can say that x equal to 0. It is fine because of 0 which is in the first region, first quadrant, right? In case of n equal to 1, I can say that x equals to pi. But where the pi lies either in the second or third. In second and third quadrants, if you focus, cos x is clearly negative in case of pi plus or pi minus, right? But what we have considered in case 1 is mod cos x equal to cos x, so that x equal to pi strictly rejected, right? Now move on to n equal to 2, so that it is x equal to 2 pi, then 2 pi it will be in, if after completion of one revolution, right? 2 pi plus or 2 pi minus, whatever it may be, it will be on the first or fourth quadrants. So clearly we can consider this, and in case of n equal to 3, I can say that x equal to 3 pi. 3 pi is anyway 3 pi plus 3 pi minus will be in the second and third quadrant, where cos x will be negative. So this is solution also strictly rejected. So what solutions we are rejecting clearly are the multiples of pi, and what solutions we are considering here is even multiples of pi. So clearly so many people will think that x equal to n pi will be the final conclusion, but coming to the reality, x equal to n pi where n belongs to I is not a solution, but x equal to 2n pi even multiples of pi where n belongs to I is the solution for this case 1. But that solution is not present in this, but x equal to n pi, which makes us to take the answer that x equal to n pi, but don't go for the wrong option, right? Now move on to case 2. Then I can say that, for suppose mod cos x equal to minus cos x. In case of mod cos x equal to minus cos x, because the first condition what we have considered is mod cos x equal to cos x, here mod cos x equal to minus cos x, it is possible in second and third quadrants, right? In second and third quadrants cos x is negative, so that mod cos x I can say that minus cos x. So minus cos x equal to cos x minus 2 sin x. So clearly minus 2 cos x equal to minus 2 sin x, both will get cancelled, and I can say that tan x equal to 1, and in case of tan x equal to 1 I can say that it is tan pi by 4. So clearly x equal to n pi plus pi by 4 where n belongs to I, and there will be option that x equal to n pi plus pi by 4 when n belongs to I. Don't think that this one will be the final general solution because of, let me verify with one n equal to 0, right? In case of n equal to 0, I can say that x equals to pi by 4, where that pi by 4 lies in the first quadrant. But in the first quadrant, cos x is positive. But here what we have considered is mod cos x equal to minus cos x. So clearly the solution should be in the second and third quadrants. But here x equal to pi by 4 is in the first quadrant. This solution is straight away rejected. So n equal to 0, we can't substitute. N equal to 1, that is x equal to pi plus pi by 4. So that pi plus pi by 4 is in the third quadrant. So that this is okay, fine. So that it is 1 multiple of pi plus pi by 4, right? In case of n equal to 2, so that it is x equal to 2 pi plus pi by 4. In case, what is 2 pi plus pi by 4? 2 pi plus pi by 4 is in the first quadrant. So in the first quadrant anyway cos is positive, so that case 2 is not possible. Now 2 pi plus pi by 4 is also straight away rejected, right? Now what about n equal to 3, that is x equal to 3 pi plus pi by 4. Now 3 pi plus pi by 4 which lies in the third quadrant again. So this will be the possible solution. Now clearly, so what's going on here, in case of even multiplier it is not possible. Let me verify with one more value, that is n equal to 4. Then x equals to 4 pi plus pi by 4 is in the first quadrant, straight away it is also rejected. But if you observe, focus clearly, 1 pi plus pi by 4, 3 pi plus pi by 4, odd multiples of pi plus pi by 4 is the solution, right? Now clearly what is the solution for this is odd multiples of pi, because of 1 pi, 3 pi, that 5 pi, like that. Odd multiples of pi plus pi by 4, if you observe every solution plus pi by 4 where n belongs to I is the perfect general solution, right? Now focus clearly, odd multiples of pi plus pi by 4, and here, so clearly the first option will give you wrong solutions, second option also will give you wrong solution. In case the third option is not there in that, right, which is impossible, third option. Now the correct answer is fourth option. Thank you.